Good morning once again, guys. So far, what we have discussed in our lesson on multiple regression is we have learned about the structural form of our regression line. Okay, we have learned also about the assumptions. These are very important assumptions. So when we have generated a regression line model, we will have to check if they comply with the requirements for a classical linear regression model. And we said that we want that our model to be BLUE, the best linear unbiased estimator. And it will be BLUE, guys, if our model follows the assumption of our linear regression model. That being, our data is linear with respect to the relationship between your response variable and your predictor variables. The parameters should be linear also. The residuals should be constant variance of the residuals, which means no trend when you plot the residuals, no fanning out or fanning in of the residuals. It should be constant across the values of your residuals. And then the explanatory variables should not compete with each other in trying to describe your outcome variables. So dapat walang multicollinearity. And the residual should be independent. And then your residual should be normally distributed. Okay, so let me just run the packages that we need. Okay. Let me open. This is the file that I sent you, diba? Let me use this so that I don't have to write the code. Okay, I gave this file, right? Kasi sabi natin dati may mga deliberately, guys, may mga blinank ako ng mga codes for you to write on. Okay, so we were using the wage data. Sorry, hindi ko pa pala na-import. Apologies, guys. So let me import the data set. If you have not done so, guys, kindly import it now. Okay, so wage. Let me copy this here. Okay, wages here. Okay, so we were working on this last time, guys. Our outcome variable here is our hourly wage. We'd like to investigate whether education can describe hourly wage. Hourly wage is our outcome variable, or our response variable. Education was a variable that we use to be our explanatory variable. Okay, so I'll not run that anymore. I won't run anymore the descriptive statistics. Okay, this one I'll convert them to factors. Okay, all right. So let's have a quick review of our first model. Our first model, guys, we named it as mod 1. We use the LM function, a linear model. And how do we go about it? We identify our outcome variable, and then tilde, you have your predictor, education, and then you define the variables that we're using. Okay, so when we run this, guys, it will generate the summary. The summary function will generate the formula that we use the coefficients, intercept, and education. Okay, and then the residuals, the descriptive statistics of the residuals, and then the individual tests of the coefficients. Okay, I think we studied this last time. We said that our intercept, which is the value of your outcome variable, your hourly wage, if all your predictors are 0. So this is negative 9.045, and we said that actually this does not have any practical meaning, because how can you have a negative hourly wage? So does that mean that it's the employee that's going to pay the company? And we see that it's not statistically significant. Sabi natin that the p-value should be less than 0.05. Okay, so just a very quick review, guys. P-value should be less than 0.05. Okay, for us to make a conclusion that about our statistical test. Okay, so this one, guys, this coefficients result here, this has a statistical test that comes with it. So ano ba yung statistical test natin dito? Our statistical test here is that our beta null B0 is equal to 0. Okay, so this is what we are testing. Our intercept beta null is equal to 0. And what's our conclusion? What's our inference? We reject this null hypothesis. Okay, so we're rejecting this null hypothesis that are in. Oh, sorry, my bad. We fail to reject. So we fail to reject the null hypothesis. Our null hypothesis is beta null, like this, H null. Beta null is equal to 0, and we fail to reject it because the p-value is not less than 0.05. So there's strong statistical reason to believe that our intercept is could be 0. Okay, so we fail to reject this. However, guys, yung intercept, we still include that in the model. Okay, we still include that as part of the model in predicting our outcome variable. Okay, that's a standard practice, unlike the predictor itself. So in this case, education is 0.54, and it's statistically significant. Okay, so when it's statistically significant, the p-value is less than 0.05. So what was the null hypothesis here? The null hypothesis here is HO2. Okay, this is HO1. Second null hypothesis is that our beta 1, B1, is equal to 0. So notice, guys, I'm just going through this because you have already discussed this in several of your statistics subjects before. So in this case, we reject the null hypothesis. Okay, the p-value here is less than 0.05. So reject HO. Reject HO. Why? Because your p-value is less than 0.05. And the general rule is when the p is low, the null must go, or we should reject the null hypothesis. When the p is low, the null must go. The p is 0.05. Okay, it's lower than 0.05, then we reject the null hypothesis that B1 or education is equal to 0. So there's this strong statistical reason to believe that the coefficient of education is a value other than 0. And here it's 0.54. So how do we interpret 0.54? 0.54 is interpreted as for every 1 year increase in education, there's a corresponding $0.54 because hourly wage is in dollars. 54 centavos US cents increase in hourly wage ceteris paribus. Okay, for every 1 year, where did I get year? I got it using the parameter of the dimension of your independent variable. Education is expressed in years, so I'm going to use that as in order to describe or explain the effect of education. For every 1 year increase in education, there's a corresponding 0.54. 0.54 what? Hourly wages in dollars. So I'm going to say $0.54 increase. Why increase? Because this is positive. Increase in what? In hourly wage. And then comma, okay, or let me write, for every 1 year increase in education, there is a corresponding dollar, $0.54 increase also in hourly wage, ceteris paribus, which means all things being equal, all things being the same. In other words, guys, if I let education, this is particularly true for multiple regression. If I increase education by 1 year, hourly wage will increase by 0.54, assuming that the others will not increase. Okay, assuming that the others remain constant. So I'm not going to increase the other variables if there are several variables. Okay, so that's what we looked at last time. Okay, so continuing. Okay. And then here we plotted the regression line, okay, very quickly. Oops. What did I miss here? Walang data to. Data is equal to wage. Okay. Wage, hourly wage, wage education. Okay, so this will be okay now. All right, so this is our regression line. This is the line that we're using in explaining or predicting our outcome variable hourly wage. Okay. All right, so the model 1 object, guys, which we use to name our regression output, it's a list. If you take a look at this mod 1 here, mod 1 is a list, which means it contains several data with it. So there's this coefficient, which is a vector, negative 9.05. May residuals then, mga vector, mga with decimal places to, my rank, my fitted values, etc. So the object mod 1 contains several 12 items. No? Some are vectors, some are also lists. Okay, so let me so we can access the data under model 1. Okay, I'll not go do that, guys. We already did that before. Okay, but there's a package Broom, and we can generate this. Okay, we can use the Broom package and use the augment function. Okay, so let me source this out. Let me load this, and then I'm going to create here mod 1 diagnostics.metrics and see what this generates. So, dito siya, no? Model 1 diagnostics.metrics. It consists of 526 observations of 8 variables. So it's similar to asan si wage natin. Si wage 526 observations then of 8 variables. But let me see what this consists of. Ito. All right, so we have here your dependent variable hourly wage. You have your independent variable education. Then you have here some computed statistics. No? You have your fitted values. You have your residuals. Okay, you have your standard deviation here. Then the Cook's distance and then the standard residuals. Cook's distance is used to identify if the particular observation is an outlier or an influential points. Saka natin titinan yan. No? Okay, so instead of just getting the residuals, for example, from the mod 1 package, from the mod 1 object, okay, we can use the Broom package to generate the values for the residuals, for the predicted values, etc. Okay, then here, what we did last time was to plot. Okay, we would like to see here, we use ggplot2 in plotting yung model 1 diagnostics natin, where we plot education and hourly wage. This is your independent variable. This is your predictor. This is your outcome variable. Then we're using geom point. Then nagdagdag tayo ng statistical smooth method using LM. And then may segment din tayo inad dito. And nilagyan natin dito kung saan mag-e-end yung x-axis and then saan mag-e-end yung y-axis. Okay? So we can see here a plot of okay, ayaw nyo. Kailangan mo to-start ako. Okay, guys, we were able to run this last time, diba? Right? Guys, tama ba? Hello? Okay, yes. Run na natin to, no? Pag hindi nag-run sa akin, guys, okay na. Okay. Let's see. Kasi mag-reinstall ako eh. One or more. Starting. Okay, sige. Sandali lang naman to, no? Start ko lang muna siya. Okay. And then, dito na tayo sa pag-plot ng residuals. Any model, guys, any model that we generate, we have to do diagnostics. Pag sinabing diagnostics, we have to study the residuals. Okay, are the residuals homoscedastic, constant ba yung variance niya? Do the residuals display a normally distributed by residuals? Okay, so because if not, guys, then we will not have a blue model, the best linear unbiased estimator. Okay, so I'm going to plot here. Restart ko siya. I don't know if I can run this. Let me see. Now, ito guys, itong code na to, par, this is actually for parang partition siya, no? Or parang parts or partition. And then I want it, yung ano niya, yung size niya will be 2 rows and 2 columns. Tapos ano ipa-plot ko? Yung mod 1. So we use this guys to plot for the diagnostics. So sige, i-plot muna natin to. Okay, so we have here the diagnostics for our residuals. 2 rows and 2 columns. So this gives us an idea kung ano yung behavior ng ano natin, ng model natin. For example, ito sa normal QQ, normal quantile plot. This tells us if our data, if our residuals is normally distributed. And if you can see here, there's a number here. It tells us the possible candidate of a influential point or an outlier. Okay, an influential point is an observation that can affect the result of your model. Okay, pag tinanggal natin kunyaring point na yan, malaki yung magiging effect sa model. May iiba yung model natin. Yun ang ibig sabihin yan. So there are tests, guys, to see if these are really influential points. An outlier, this is definitely an outlier. an outlier may or may not be an influential point. However, all influential points are outliers. Okay, let me repeat that. Diba nung pinat natin yung yung box plot, guys? You can see if there are outliers. Okay, an outlier, okay, means that it's outside yung natin, yung IQR natin. And an outlier can be an influential point. Ibig sabihin, it doesn't matter, pag hindi siya influential, it doesn't matter if that point, that sample is included in our model. It will not affect the result of our regression output. So that's not an influential point. On the other hand, an influential point will affects the model, the regression model, because of its presence. Okay, so there's this decision now whether an outlier is an influential point or not. And then if it's an influential point, what do we do with that? Okay, kasi possible na influential point kasi nagka-error dun sa sa pag-encode ng data. Okay, pag hindi naman, then we have to make a decision kung tatanggalin ba siya o hindi. Kasi pag legitimate na legitimate na data, then many would say na leave it there. No? May iba naman nagsasabi na use imputation. Yung imputation naman, ang gagawin doon, papalitan yung influential point niya ng, so it could be a median, it could be a mean, etc. But others are against that kasi ang sinasabi na that will bias the data. That will make the data biased. Okay, anyway, wala pa tayo doon, ano? So I'm just telling you that this point ba to 126, this could be an influential point. So itong normal quantile plot na to, this is used to determine if the residuals are normally distributed. So dapat guys, yung residuals natin, yung standardized residuals, they should follow along this one. Dapat malapit sila sa line. Okay? So kapag medyo malaking deviation nila dun sa line like this one, then that indicates that our residuals is most probably is not normally distributed. Okay. The others guys tell us if the if the residuals are homoscedastic or they suffer from heteroscedasticity. Dito na naman guys si 126, no? May 112 din, may 15 din dito. So these are outliers which could be influential points. So here we can see that, you can see here the red line, okay, medyo may trend siya, no? Medyo hindi siya, it does not seem to fit or does not follow the dotted line here. Pag ganyan guys yung plot ng residuals, it is indicative that there's heteroscedasticity. Ganun din sa scale location, pareho lang siya. No? Iba lang yung pinaplot dito. Sa unang plot guys, ang pinaplot dyan yung residuals. Okay, sa pangalawa is the standardized residuals. Okay, but both of them are plotted against the fitted values, yung predicted values. Okay, so dito din guys, makikita natin na there seems to be a pattern. May shape, hindi siya straight line. And ganun din dito guys. Ito naman yung residuals versus leverage. This tells us also about yung presence ng influential points. Sabi natin, di ba, yung Cook's distance will determine if a particular point is influential or not. Okay, so just be aware of that. We will go back to that next time. Okay, and then meron ding you can plot also using GG45, library ko muna to. And then i-auto plot ko siya, model 1. And difference ito auto plot, yung isa naman plot. Ito we needed the GG45 package. Isa naman GG plot lang. So anong difference siya guys? Mas well for me, no? Mas maganda yung pag-plot ng using GG45. But they're the same thing. Okay, so meron ako ditong konting discussion guys. In plot number 1, it's the residuals against the fitted values. So ano sinabi natin? It's used to check linear relationship assumptions. Okay, a horizontal line without distinct patterns is an indication for a linear relationship, which is good. No? Okay, so hindi lang yun, no? Hindi lang yung linear relationship ang tinetest itong residual versus fitted. As I mentioned a while ago, it tests for heteroscedasticity. So kung medyo hindi siya sumusunod dun sa dotted lines, guys, then it's indicative that there might be heteroscedasticity itong dotted line ito. Okay. So number 2, guys, yung normal QQ, sabi natin, it's used to determine whether the residuals are normally distributed. It's good if the residuals are following the quantile plot. Otherwise, kung malayo, guys, ibig sabihin, yung residuals natin hindi normally distributed. Okay, ano naman yung number 3, yung scale location? Ito yun. This is the scale location where we plot the square root of the standardized residuals against the fitted values. Okay, so what this gives us is the homogeneity of variance, yung homoscedasticity. Okay, so dapat, guys, yung sabi natin dito, the horizontal line is a good indication of homoscedasticity. In our case, mukhang may, ano tayo, no? Tignan nyo to, no? Okay, kasi tingnan natin, even here, yung mga plots, no? Yung mga residuals natin, diba? Over the fitted values, guys, lumalaki siya. No? Dito, panay dito lang siya at this point. As the fitted values increase, guys, ano nangyari sa mga natin? Sa variation ng mga residuals natin, lumalaki siya. So this is an indication of may fanning out. No? So that means that our model might suffer from heteroscedasticity. And then, ito din, guys, ito yung sinasabi ko sa inyo, yung residuals versus leverage. It identifies influential cases. Extreme values that may influence the regression results. So may naka-identify dito based on Cook's distance. No? Yan, so si 379, si 112, at saka si 59. Wala ba siya dito? 379, 112, 59. So these are points that you should look into because they may be influential points and they deserve further investigations. Okay, now let's go, guys, to multiple regression. Okay, so redundant na to, ano, kasi nagawa na natin to, na-as factor na natin to. Okay. All right. Sa site package, guys, you can plot the pairs that panels function. So let's run this. Okay, so what does this give us? It's a correlation plot. It gives us both the diagram and the magnitude of the correlation among the variables. Okay, let's see. Si education, guys, gusto natin to na mataas to, no? Sorry, si hourly wage. Okay, where's hourly wage? Si hourly wage, ito. Here, this one. We would like the dependent variable to have a very high or a high correlation with the independent variables. Of course, walang kinalaman yung mga ano dito, ano yung mga factors, yung mga categorical variables. Pwede naman natin matanggal yan, but not now muna. No? Okay, si hourly wage correlated with the education, 0.41. Okay, so medium yung correlation nila. But the others, guys, with race, gender, civil statuses are factors. Tenure, 0.35. Experience, 0.11. Okay. Number of dependents, negative correlation tapos mababa pa, 0.05. Very weak yung relationship nila. So chances are, guys, pag nag-multiple regression tayo, maybe number of dependents will not be a significant predictor of hourly wage. But we don't only look at the relationship between hourly wage and the independent variables and our predictors. We also would like to look at the relationship between your independent variable with your other independent variables. Okay, for example, si education. Okay, si education. Ito yung mga correlation na. No? Okay, so education, negative 0.3 with experience. So negative correlationship with education and experience. Okay, is that a strong relationship Well, we'll see, no? We'll see when we do some tests. So education with tenure, mababa. So okay lang to, no? Education with race, hindi kailangan yan. Gender, civil status, these are factors. Number of dependents, negative 0.22. So medyo weak ang relationship. Education with the others. And then ito, with hourly wage, ito maganda. Okay, so that's what I'm saying here. You have to inspect also and see. So experience with, how about experience with with tenure, no? Ito, 0.5, medyo mataas. Okay, 0.5. Experience with number of dependents, wala. Wala kinalaman yung experience with, mababa siya, no? Okay, and then tenure with number of dependents, mababa din. Okay, the factors, we will not consider that kasi mga factors yan. So walang meaning yung yung correlation. Okay, so clear guys itong plot na to guys, which we use in pairs.panels. So this is one of the best for me. May iba pa, may core plot pa na iba, pero sa akin maganda tong from the site package yung pairs.panels function in order to establish the linear relationship between your variables, whether it be your independent variables or your dependent variable. And let me pause for a while. Any clear so far, guys? Kindly chat, please. Is this discussion clear, guys? By the way, guys, team plot, no? Ito yung scatter plot ng education at saka example. Ito yung yung univariate plot niya, yung histogram ni education. Tapos ito yung plot ng education at saka ni experience, no? Yung correlation nila. Yung scatter plot nila. Okay, 5 pa lang guys, yung out of 21 students. How about the rest? Baka gusto nyo magbigay ng feedback. 5 guys is a small number. 1/4 lang siya. No? Just 20% of you responded if this is clear. Yung site natin, yung parts.panel, pairs.panels. Okay, thank you. Thank you guys. A few minutes, a few seconds more guys, to give chance to the others to key in the response kung okay so far itong So just also remember guys, na sa site may magandang function siya, pairs.panels. Of course guys, you can dispense with putting this. I deliberately placed it here so that alam natin kung saan nanggaling package ng pairs.panels. Okay, thank you guys, thank you. There were some who have not yet responded, pero sige, tuloy na tayo kasi we're like to maximize our time. Okay, all right. So now, I think we stopped here last time. So now guys, we begin with another model. Yung unang model natin, simple linear regression yun eh. So this time, we're going to do multiple regression tayo. Did I write that? Okay, multiple regression. All right, so we're creating an object called mod2. Okay, ano yung mod2 guys? We're going to regress si hourly wage on all the variables. Si education, si experience, si tenure, si race, si gender, si civil status, si number of dependents. Now let me just check guys kung it's important for us to check. Let me just check yung structure ng wage. Just to check kung naka-factor na yung yan. Factor na sa civil status. Civil status, race, factor, gender. Okay, good. So that's what we need. That's what we need to transform yung mga character variables niya. No?
Okay, so how do we generate linear regression, multiple linear regression model? Same thing, guys. The only difference is that there are now several predictors: so education, so experience, tenure, race, gender, civil status, number of dependents, and data is equal to wage. Now, if you have a long list of predictors, pwede rin ganito. LM, okay, hourly wage, tilde, and then dot. The dot here indicates that we include all the other variables from the data wage. Okay, so let's run module 2. Let me run this. Okay, take note, guys, inano na siya, pinarenthesis, ano? Tapos, what we find here are the coefficients. So ito yung coefficients ni intercept, education, experience, etc. Okay. So let me see if this will run the same. Pareho lang, guys. So pareho lang siya ng result. Same result, guys, as the tilde, and then you specify all the independent variables, or tilde dot. Okay, dot here indicates that we regress hourly wage on all the other variables. Okay, let's summarize this, guys. Summarize. Okay, so we have here the output of our LM function. This is the formula, LM, hourly wage, regressed on all the variables, data is equal to wage. Then we have here the residuals, minimum value, maximum value. Okay, we can see here that malaki yung maximum kaysa sa minimum. No? And the median is negative. Okay, we have to know the mean in order to see if it's concentrated, if it's skewed to the right or skewed to the left. Okay, here is the individual t-test. No? Individual t-test, where we are testing each of the significance of each of the variables. Okay, by way of review, guys, itong intercept na to, ang individual t-test nito, ang hypothesis nito, if you recall, beta null is equal to 0. Diba? HO1. And our conclusion or inference is 3 stars here, guys, indicate that it is significant at 0.001. Okay, itong 3 stars sila yun. Significant at point, yung katabi niya, to the right, 0.001. Okay, pag 2 stars, ibig sabihin it's significant at the 1% level. Pag 1 star, it's significant at the 5% level. Pag dot, ibig sabihin it's significant at the 10% confidence level. If there's nothing, guys, then ibig sabihin not significant siya. Okay? All right. So education, guys, no? It's also significant, 3 stars, significant at the 0.1% level. And the value is 0.57. Medyo naiba siya kaysa dati kanina, diba? Okay, let's quickly interpret this, guys. Ano ibig sabihin nito? What does this mean? For every 1 year increase in education, there's a corresponding $0.57 rounded, no, to the nearest 2 decimal places, increase in hourly wage, and then comma, ceteris paribus. Ano ibig sabihin ceteris paribus? Same lang yung level ng experience, tenure, race, gender, civil status, number of dependents. Huwag silang dadagdagan. Yun ang ibig sabihin nun. Okay? Ang dadagdagan lang natin, 1 year ng education. Do not add 1 year in experience. Okay, so that's what that means, yung ceteris paribus na yun. So, for every 1 year increase in education, there's a corresponding 57 centavos, US dollar centavo, US cents, no? In hourly wage, comma, ceteris paribus, or all things being equal. Okay? Okay, number 2, experience. Experience is significant at that to, no? Yan, that to, at 10%. Kita nyo naman, 0.07. Okay, so what does this mean? For every 1 year increase in experience, there's a corresponding 2 centavos, no? Increase in hourly wage. Okay, again, comma, ceteris paribus. Okay, pause muna ako, guys. Are you able to understand yung ceteris paribus ko kanina? Guys, yung ceteris paribus. Ibig sabihin, all things being equal. So that's what we use when we interpret each
of your independent variables and its impact on the uh, outcome variable, which is hourly wage. Clear ba yung guys? Paki-chat naman please kung clear yung interpretation natin ng education, ng experience, yung mga parameters na to, yung mga values na to. Thank you. Tatatlo pa lang guys. Okay. Ano pa bang iba? I have here 21 students, guys. How about the rest? I'm hoping for a 75% response, guys, from you. Okay. Baka almost half pa lang ako. Very good. Thank you so much. How about the rest, guys? If you have any questions, please feel free to ask your questions. Don't be ashamed. Okay. How about the rest? Kulang pa tayo. 11 pa lang guys yung nag-respond. So, it's just about 50%. What about the missing 10 students in this class? Are you still here? Have you left the session? Or do you have any questions? Feel free, guys. Let's give our classmates a few more seconds. Okay, thank you. Okay, sige. Thank you so much, guys, for your responses. Sana ganun lagi, no? Para guided ako. It's for me also. It's not only for you, but it's for me to be guided. Okay, tenure, guys, it's also number of years, no? Number of years in the company. So this is statistically significant at 0.1%. Okay, notice, guys, na pag malaki yung t-value, notice 11, 6. Ito 0.257. Okay, 0.257, not significant. So the higher the p-value, the more significant your variable is. Okay, the more it will be less than 0.05. Okay, so how was this p-value generated, guys? If you recall from your stat, it's equal to your estimate. Your estimate divided by your standard error. Yan ang formula, guys, ng t-stat natin. Negative 3.659. Okay, ito yun. And it's used to determine whether it's then be converted into the p-value. So just be reminded, guys, I'm sure you took this in your previous stat before. So your t-value is equal to your estimate, okay, your beta, divided by your standard error. And then convert this into p-value. Actually, we can use this, no? We can use this to determine if it's significant or not. Pero mas madali kasi yung p-value, kaya ito yung ginagamit natin. Okay, so if we're strict about the confidence level, yung level of significance na 0.05, then dito, what's our null hypothesis here? Our null hypothesis there, it's HO2 na, no? HO2. That's beta 3 na. The beta 2, B2 is equal to 0. Diba? So this is your B null, B1, B2. This is your B2 is equal to 0. And what's the conclusion here? We fail to reject. We fail to reject the null hypothesis that B2 is equal to 0. Okay, so strong statistical possibility that your experience is 0, which means wala siyang kino-contribute sa pag-explain kay hourly wage. Okay, yun ang ibig sabihin ng guys, diba? Pag hindi siya significant, and we cannot use that in the model. Okay, next. About this, si tenure. Si tenure din number of years, no? Tenure is number of years, so ano ibig sabihin nito? This is highly statistically significant, okay, at 0.1%, way below 5%. So ang sinasabi natin dito, for every 1 year increase in office tenure, there's a corresponding 13 centavos or 14 centavos increase in hourly wage, comma, ceteris paribus. Okay, ceteris paribus. All right.
Okay, I hope guys clear yung pag-explain natin ha. Then let's huli na natin tong yung iba na to. Okay, number of dependents. Ano ibig sabihin nito? Number of dependents guys, okay, it's not significant, no? It's not significant. So no use interpreting this. No use interpreting what this means yung 0.40 na to kasi hindi naman siya statistically significant and it will not enter our model. If this was your final model. Okay, let's go now to the factors. Kasi ito yung mga factors natin. No? Race, gender, civil status. Now take note guys, ang ginawa niya dito, race, tapos white, gender, male, civil status, single. What does this mean? Bakit may race, nilagay niyo yung white? Bakit ganun guys? Okay, tingnan mo natin yung wage natin. Let me see wage. Okay, ito yung tatlong factors natin. No? Race, gender, and civil status. Okay, now si race, dalawang klase siya. White at saka non-white. White at saka non-white. Diba? Once again, how would you know that, guys? Dati, di ba ang ginawa natin? Binagay natin sa structure, makikita sa summary. Makikita natin yan, diba? Summary ng wage. Okay, summary ng wage. Yan. Race. Non-white at saka white. Gender, female at saka male. Okay, civil status, 320 at saka 206. Okay, what happened here? Race at saka white. Ano ibig sabihin itong race at saka white na ito? Anyone, guys? Very explicit dito si R. Ang R is telling us that among this non-white at saka white, among this non-white at saka so white, the white race will be our benchmark.
Sir, so is white race the 0 or the 1?
No, sorry. Si white race, guys, siya yung 0. No? How did R do that? Si R, ang ginagawa niya alphabetical. Okay, so alphabetical natin, guys, non-white at saka white. Yung alphabetical, yung mauuna, guys, that will be the 0. Okay? And the white will be 1. Kaya yun na linagay niyo dito. Race, white. Yung white siya yung white na race siya yung 1. Wait, so dito ako. Alphabetical 1, okay. Dali guys, medyo nalito lang ako, no? Kasi dito, okay. Interpret muna natin 'to, ha. Okay. Para for me to correctly answer the question kung anong ginagawa. Kasi pag factor, guys, okay, let me first explain what happens. Pag factor, ang ginagawa natin, guys, dito, one of the variable will be used as a benchmark. So gagawin siyang 0, no? Okay, the rest will be 1. Let me repeat that. So kunyari, female, dapat, female, yung race mo na non-white at saka yung white. Non-white at saka yung white. Okay, what will happen? What will happen, guys? Non-white at saka white. What will happen is that yung isa dyan, guys, yung isa sa dito, yung isa sa non-white at saka sa white, gagawin siyang 0, yung isa gagawin siyang 1. So what's the effect? Yung isa gagawin 0, yung isa gagawin 1. What will happen? What do you think, guys? If one will be made 0 and the other one will be made 1.
Sir, you'll be able to make sense with what? With the coefficient of the
Makes sense? Okay.
yes.
Alright, thank you. Thank you for that. Pero hindi lang yung make sense, no? Ano muna mangyayari? Ang mangyayari muna guys, kasi, batiin natin ito ha. Nasaan yung wage natin? Ito yung wage natin. Diba ito? Diba this was converted into factors, no? Factor na to. So classifier na siya. So by default guys, this would be converted into 0, 0 and 1, no? 0, 0 o 1. Sino magiging 0 dito? Sino magagawing 0? What do you think guys? Sino yung gagawing 0? Sino yung gagawing 1?
Sir, non-white po ba? Kasi yun yung first in the alphabet.
Okay? So, alphabetically, gagawin si non-white ano?
0, sir.
0. Okay. So, gagawin si non-white 0, tapos si white gagawing 1. So, what will happen here guys, mathematically, is that lahat ng mga white dito gagawin 1. Okay? So, if we are going to copy this in Excel, sige, let me... Okay, buksan nyo nga guys yung ano, buksan natin yung ano, yung, let's do that na lang. Let's open the wage. Buksan natin yung wage na, ano, na file, CSV file. Just for us to understand what happens with yung ginagawa nating dummy variable. Okay. So di ba ito guys si si white, no? Ito si white. So ang gagawin ni Arjan, and even sa Excel guys, one will have to be replaced by 1 and the other one should be replaced by 0. Okay, so ang tanong, ano ginagawa ni R na ano na 0 or 1? Alphabetically guys, si non-white at saka si white, no? So si non-white gagawin yung ano? What do you think guys? Kasi dadalawa lang yan, white at saka non-white.
Sir, 0 and 1 lang po.
Yeah, sino yung 0? Yeah, 0 and 1 lagi guys.
Po.
So sige, okay. Sa non-white 0, no? So let's do this, no? So let me just replace that is equal to if, gawa tayo ng if this is equal to white. Okay, mas madali ito. No? I'll put here white. Okay? So, ang linagay ko dito guys, yung gagawing number 1. So, let me write this formula. If this is equal to, if is equal to if this is equal to this one, okay, and then I'm going to fix this. I'm going to fix the row. Okay, kasi kakapit ko pababa yung formula natin. If this is equal to white, then give it a value 0. Otherwise, give it a value 1. Otherwise, give it a value 0. Okay, so ito, nangyari guys, yung white is 1. Okay, tapos, if we copy the formula down, okay, notice guys, lahat ng non-white, 0 na siya. Okay, di ba lahat ng non-white 0 na? Okay? Ganun din dito guys sa gender. Sino yung gagawing 0 dito? Alphabetically, female, male. So ang mangyayari dito, ang 0 will be your female. Ang male will be the 1. Lagyan natin dito, male. Okay, so ganun din yung formula, no? Okay, is equal to if. In fact, pwede natin i-copy yung formula na to. You can copy it here. Yan. Kasi, Phoenix natin yung yung dito sa gender. No? Okay, ganoon din dito guys sa dito naman sa civil status single at saka married. So ang gagawin ditong alphabetically si married yung si married yung 0, si single yung there. Single 1 siya. No? Copy this down. Okay. So what happened was, guys, we now have, well, in a sense, parang naging number na siya, no? 1 and 0. Okay, so sa race, guys, lahat ng white 1. Sa gender, lahat ng male, 1. Diba? Female, female, male. 0, 0, 1. Lahat ng single, 1. Okay. Let me pause for a while, guys, to let you catch up. I hope you're also doing this in your CSV file. Clear ba so far? Okay. Sige, i-assume natin to guys ha. Magpapakita ko sa inyo kung tama ito o mali. No? Okay lang guys kung mali yung unang sagot natin. Kasi what's important is for us to understand. I'm going to show you sa interpretation natin. Okay, clear ba so far? Nagawa niyo na to guys? This is what happens, guys, when we replace yung mga factors. No? So, nasa behind the screen, behind the monitor, guys, ito yung ginagawa ni R. Pinapalitan niya yung mga character variables, yung mga factors na ones and zeros. Okay, what happens, guys, if, kunyari, tatlong levels. Kasi, gawa tayong ganito. No? Kunyari, junior, so, frosh, sophomore, senior, frosh. Kunyari ganito guys yung frosh, junior. Okay. Okay, what if we have several levels? Kunyari ito 4 na levels. Junior, junior, frosh, sophomore. Okay. All right. What will happen here, guys? Diba, introduce lang 0 and 1. Hindi naman 0, 1, 2, 3. No? Okay, the rule is, guys, kung ilan yung levels ng factors natin, we will need to introduce K-1 dummy variables. Kasi ito, this is what we call, guys, dummy variables. So yung factor natin, convert into a dummy variable. So for race, ilang dummy variable ang in-introduce? Isa lang. Ito lang. Saan natin nakuha? Paano natin malalaman na isa lang? The formula, guys, is K-1. What's K? K is the number of levels. So si gender ba? Si race, ilang levels? Race has 2 levels. White at saka non-white. So 2 minus 1, therefore, isang dummy variable lang yan. How about si gender? Ilang levels to? Female, male. So how many dummy variables? Ilang levels ng ni gender? Dalawa. Si female at si male. Ilang dummy variables ang introduce na yan? K minus 1. 2 levels minus 1, that's 1. So, isa lang in-introduce natin. Ito lang. How about si single, guys? Si single status, single married lang yan. Dalawang levels minus 1, isa lang. How about ito, year level, guys? Year level.
Sir, 3 dummy variables.
Correct. Because there are 4 levels here, di ba? So K minus 1, that's 4 minus 1, there will be 3 levels of dummy variables. So if R will do this, anong gagawin niyang ano yung gagawin niyang 0?
Frosh, sir. Sir, although in R, I think hindi niya ginagawang ganun. Kasi before we did multiple regression with R, and parang ginawa niyang ano pa rin, parang I think pinaghiwa-hiwalay niya, like Frosh, sophomore, then senior. Then parang naging baseline niya. I mean, yung 0 yung naging baseline niya, then parang tigi-isa po siya.
Yeah, exactly. That's what happened, no? That's what happens. So we said that there should be 3 dummy variables. No? Ano yun, yung 3 dummy variables na yun? So si Frosh magiging baseline, di ba? Tama? Sino yung sumasagot kanina? Sorry, hindi ko nakita.
Si Justin po, sir.
Justin, yes. Thank you, Justin. Justin is correct. So, ang mangyayari dito, guys, so, yung alphabetically, yung mauuna, si Frosh, siya yung gagawin 0. The rest will be your dummy variables. They will be 1. So, kunyari, so si Frosh, siya yung 0, di ba? So, sino yung magiging mga dummy variables natin? Tatlo siya. Si Junior, okay? Sino pa? Si sophomore muna. Sophomore, and then si Junior, and then si Senior. Okay? Alright. So, plot lang natin, guys. Is equal to if this is equal to this. Tapos ito pala, this na to, guys. This should be fixed. No? If M2, kailangan i-fix natin to. Fix natin yung M to M para hindi siya aalis dito sa column M. Is equal to N1 and then fix natin si 01. There. That should be the proper code in Excel, the proper function in Excel. If that one is equal to sophomore, then it should get a value of 1. Otherwise, 0 siya. Okay? Yeah. So that's the simple code. Alright? So 0 nga siya. Copy to the right. Okay, copy to the left. Okay, let's see what happened, guys. Diba, ito lang, guys, yung ano natin, ito lang yung variable natin. Year level, kunyari ito. Year level. Level na lang. Status na lang. Kunyari. Status. Okay, junior siya. Okay, paano natin i-replace si junior? Junior will be replaced by 3 dummy variables. Lahat dito, guys, marireplace siya ng 3 dummy variables. Si status, 3 variables siya ang marireplace sa kanya. No? Ang i-replace niya. Si junior will be, ito siya. 1 siya sa junior. Si Frosh, 0, 0, 0. Okay? Frosh ulit, 0, 0, 0. Not sophomore, not junior, not senior. Sino siya? Frosh. Si sophomore, magiging 1 siya dito kay Soph. 0 kay junior, 0 kay senior. Si senior naman, 0, 0, 1, etc. Okay? Guys, clear ito? Clear? Let me summarize ulit. Yung mga factors, guys, very important yan kasi it allows us to compare the effect of the independent variables on the dependent variable based on the levels. No? Based on kapag Frosh, ano yung effect sa early education? Kapag senior, junior, sophomore, ano naman yung effect? Kasi possible na magkakaiba yung effect. So how do we now convert a factor, unang-una, di ba, character muna to, di ba? Tapos ginawa natin factor. So sabi ko, behind the scenes, ang ginagawa ni Arjan, okay, mag-create siya ng dummy variables. Ang dummy variables, 0 or 1 lang naman. Okay. Kapag Excel ang ginamit natin, guys, you will need to replace this by dummy variables. Okay, ito yun, white male single, no? Dummy variables. Tapos kapag ano naman, kapag maraming levels, kung ilan na yung levels, guys, kunyari 4 yung levels, ma-minus 1 natin yan, k minus 1 lagi, and then generate k minus 1 dummy variables. Okay? So ito yung nangyayari dito, guys. So far, guys, sa example natin yan, tigwa 1 level lang. No? Tigwa 1 level lang yung ano natin, yung mga factors. Kaya, when you look at the output, yun yung output natin. Here. Yun natin output natin, guys. No? So this is our output. Here, guys. Race, white. Gender, male. Civil status, single. If this was, guys, if this was status, no? Kunyari may status tayo na variable. Ang lalabas nito, status soft, status junior, status senior. Tatlong dummy variables ang lalabas, guys. Okay, clear?
Pero sir, normally po ba, parang ginagamit talaga is, for example, 0, 1, 2, 3, if it's not processed in R? Or ganun talaga yung...
Depende sa software, no? Depende sa software. Ang alam ko Stata ganito din, no? Ang alam ko sa Excel, guys, definitely, no? Sa Excel definitely hindi kasi mapoprocess to na Excel eh. Hindi niya mararanto sa regression kasi una-una character siya, no? Tapos pag 1, 2, 3, guys, pag 1, 2, 3, magiging iba yung answer kasi yung 1, may values na yung 1, 2, 3 eh. 1, 2, 3 or 1, 2, 3, no? Kung gagawin natin 0, 1, 2, 3. So you'll have a different result. So kapag pag factor talaga, guys, ang ginagawa talaga dyan, nag-i-introduce tayo ng dummy variables. Okay, and then, so for example, ang natin, again, remember guys, pag isa lang yung dalawa lang yung levels, siyempre ang minimum level guys, pag factor, dalawa. Otherwise, hindi natin pwedeng gawing factor yun. Kasi, remember, a factor is used as a classifier. So there should be at least 2 levels. So, pwedeng 3, pwedeng 4, pwedeng more than. Okay? So, sa behind the scenes guys, kasi wala naman tayong ginawang di ba? Sinabi lang natin dito sa code natin, gawing factor tong race, yung gender, at saka sa civil status. Okay? Pero nag-generate si R ng output na race white. Now, what's the meaning of this? Ano ibig sabihin ng race white na to? What's the meaning of gender na male? What's the meaning of civil status na single? Okay? So ano ibig sabihin nito?
Sir, for race, I think it's like people of white color earns 0.10 more than non-white.
Yeah, yun ang Kaya nga, yun ang interpretation no? So, si Justin?
Yes, po, sir.
You're correct, Justin. Yun ang interpretation nun. No? So let's now go to the interpretation. Ano ibig sabihin ng mga to? So, first guys, I explained that behind the scenes, ito nangyayari. No? Ang ginagawa niya, kino-convert niya yung factor into a dummy variable. A dummy variable consists only of 1 or 0. Okay? Tapos ilang dummy variables? The formula is k minus 1. What's k? K is the number of levels of your factor variable. So as I said guys, si race, kunyari, 2 levels to. When you say levels, ilan yung kind ng race? You have white at saka non-white. No? Okay, so ang mangyayari nito, one of them has to be 0 and the other one has to be 1. Okay? So ganun din si gender, one of them has to be 0 and the other one has to be 1. Ganun din si civil status, isa doon 0 and then the other one is 1. Okay, ang tanong ko guys ganito. Tama ba to na si white yung ginawa niyang 1? Tapos si non-white ginawa niyang 0 dito? Yung ba yung ginawa ni R? Guys? Or is it the other way around? What's your opinion, guys? What happened here? So we know already that nag-dummy variable si ano no si R. Pero ang tanong, ano yung ginawa niyang 0? Sino yung ginawa niyang 1? Kasi importante yun guys, when we set the equation. When we set the equation,
Sir, I think 0 yung non-white.
0 yung non-white.
Yes.
Okay, paano mo nasabi?
Sir, kasi you mentioned that alphabetically yun yung kung ano
Okay.
yung nauna, yun yung 0.
Okay, at saka, ano pa? What if you forgot that? You forgot na yun ang ginagawa ni R.
Siguro sir, kasi white yung nakasulat. So parang white, yun yung equivalent niya dun sa estimate na coefficient.
Okay? Pero pag in-interpret natin to, okay, how do we interpret this now? On the average, sino to? Si white o si female?
Sir, white po.
Okay, correct, no? Oh. Clarify ko lang yung guys, ha? On the average, okay, nakalagay dito race white, to. So, itong point 1 na to, guys, it refers to white. In relation to whom? In relation to whom, guys? Okay. Ito yung medyo tricky, guys, ano? But, ano to? Kaya natin to, no? When you interpret yung mga factors, guys, it's always interpreted in relation to the base, the benchmark. No? The benchmark na variable natin. So, sino yung benchmark natin dito? Yung race kasi dadalawa lang yan, di ba? Dadalawa lang yan, white at saka non-white. Sino yung ginawa nating benchmark? In other words, sino yung ginawa nating 0? Yung 0 na ginawa natin, yun ang benchmark natin. Ulitin ko ha, kung sino yung ginawa nating 0, yun ang benchmark natin. Okay?
Would the benchmark be non-white, sir?
Sorry?
Would the benchmark be the non-white?
Yes, oo. Ang benchmark natin dyan yung non-white. So how do we read this? On the average, no, white employees receive $0.10096 more than their non-white counterparts. So you're comparing si white with the non-white. Okay, that's what's happening here. Kaya sinabi na kagad dito ni R, okay, this is the figure for white and you have to reference it to your benchmark, which is non-white. Yung hindi nag-a-appear dito, ito yung medyo nuance ni R, no, guys. Yung nag-a-appear dito, hindi siya yung benchmark. Okay? So you interpret this, itong point 11, guys, it's for white in reference to non-white. Okay? It's positive, no? It's positive. So ibig sabihin yan, yung mga white employees receive 11 centavos more than their non-white employees. Ceteris paribus. Okay, assuming na significant to guys, although hindi siya significant. This is 0.797. It's not statistically significant. So actually, we cannot include this in our itong specific na na to na parameter. No? Okay, how about this guys? Ano tong 1.759 na to? 1.8. It's statistically significant. So how do you interpret this? On the average, male employees receive $1.8 more than their female employees. Ceteris paribus, all things being equal. Okay. Next, civil status. On the average, single employees receive 0.46 centavos less than their married counterparts, ceteris paribus. Okay? So when you interpret yung mga factors, guys, always interpret it in the light of the benchmark variable, in the benchmark level. Now, R has made it easy. Sinasabi niya na dito kung sino yung hindi benchmark. Okay, so hindi mga benchmark to. Ang mga benchmark dito, yung wala dito, guys. Yung hindi naka-state. So our benchmark is the non-white. Our benchmark is female. Our benchmark is married. Eh, bakit pinili ni R? Well, kasi nag-automatic siya na yung alphabetical na mauuna, okay, siya yung gagawin niyang benchmark. Pag sinabing siya yung gagawin benchmark, siya yung gagawin 0. Okay? So what's the importance of making the benchmark, of making it 0 equal to 0? When you interpret the result, it should be always compared with the benchmark. So once again, guys, I hope I don't sound like a broken record. Itong factor na to na race, okay, sa iba, I forgot, guys, kung linalagay ni Stata yung white. Definitely sa sa SPS hindi linalagay. So you have to be aware kung sino yung ginawa mong benchmark. And how do you make it sa benchmark, guys? Ito yun. Ito yung gagawin nating benchmark. How do we know it's a benchmark? Ito tatlong levels. 0, 0, 4 na levels, 3 dummy variables, 0, 0, 0 siya. So, ito yung benchmark ko, Frosh. Kasi pwede naman nating arbitrarily gawing si Junior yung benchmark. So, if Junior was the benchmark, this would become 0, 0, 0. Si Frosh ngayon magiging, papalitan ko ng Frosh to. Sorry, ano na to? Si Junior gagawin kong 0. Mawawala na si Junior dito. Ano? Okay. So kung sino guys yung benchmark, siya yung 0. Okay guys? I hope medyo clear yon. No? Ang importante dito guys, yung output ni R kasi R ang gagamitin natin. So whatever the output here is, it means that white is not the benchmark. Kung sino yung wala dito, yun ang benchmark. And guys, remember, isa lang lagi nagiging benchmark. Ha? If your factor has 5 levels, only one of them will be the benchmark. And then when we generate the regression model, kunyari may factors tayo na 5 levels, magiging kunyari dito, status, sophomore, status, junior, status, senior, status, graduating. So ibig sabihin, okay, this is a factor where you have 5 levels. Okay, 5 levels. Paano ko nalaman ng 5 levels? Pare-parehong status na 4, no? Tapos yung missing isa, ibig sabihin yun yung benchmark. And then when we interpret that, guys, yung factor na yun, i-interpret natin siya in such a way that you are always referring this in relation to the benchmark. So for the last time, guys, what's the meaning of 0.10996? It means that on the average, white employees receive around 11 centavos more than their non-white employees. Ceteris paribus. Ibig sabihin, all things being equal, no? On the average, male counterparts receive 1.76 centavos more than their female counterparts. Ceteris paribus. On the average, single employees receive 0.46 centavos less, guys, less. Take a look at this. Less than their married counterparts. Okay? So next time we look at this, guys, pwede natin tanungin, teka muna, meron ano ba? May discrimination? May discrimination ba dun sa sa race? May discrimination ba sa gender? May discrimination ba sa single? Okay, we'll answer that next time. No? Suffice it to say, guys, that ngayon, yun ang masasagot natin na si race, mas malaki yung on the average si white, mas malaki si male, mas malaki si married. natatanggap relative to the uh, the the benchmark level. Okay, guys. It's time na, guys. May I have just 3 minutes, guys? Okay lang ba? Permission, guys? 3 to 4 minutes. Baka compare lang tayo. But if you need to go, guys, okay lang. Naka-record naman to. No? With your permission, guys, 3 minutes, pwede? Okay, thank you. But if you need to go, guys, go na. Okay, remember, guys, yung AIC. Sabi natin, si AIC, si Akaic Information Criterion. This, or BIC, Bayesian Information Criterion. Walang gamit yan kung hindi tayo nagko-compare. Okay, i-run muna natin to, AIC, BIC. Okay, so ito yung value ng AIC sa Model 1. Si Model 1, guys, simple regression lang yun. Diba? We regress hourly wage on education. Okay. By the way, guys, before I continue. So next meeting, sasabihin natin, so ang model natin yung mga significant lang, di ba? Ito lang, 1, 2, 3, 4. Hindi kasama tong experience kasi at 10% siya significant. So assuming that we're using a 5% significance level, only this. Ito lang yung mga significant. Si intercept, syempre kasama yan lagi, whether or not significant siya. Education, tenure, at saka si gender. Okay? So yun na ba yung model natin? The answer, guys, is no. Okay, no. That's not the way to determine your final model. Okay, ang gagawin natin, guys, next meeting, magsi-stepwise regression tayo. We will have to remove the insignificant variables one by one. Hindi pa pwedeng sabay-sabay tatanggalin na natin sila tapos sabihin natin, yung mga significant lang, yun na yung final model natin. No. We will have to perform what we call the stepwise regression. We'll do that next meeting. But just to go back here, guys. Okay, tingnan natin, guys, to. Oops, sorry. This should be BIC. I mean BID. Okay. Run natin to. Okay, take a look at the result. AIC ni Model 1, 277. AIC ni Model 2, 2640. Which is the better model? Model 2. Kasi AIC of Model 2 is smaller than Model 1. Ganun din si BIC, guys. Mas maliit yung BIC ni Model 2 kaysa sa Model 1. Therefore, guys, Model 2 is preferred over Model 1. And the statistical test to do that is the use of ANOVA, analysis of variance. So what we do here is ANOVA, Model 1, Model 2. May tawag tayo kay Model 1. Si Model 1, siya yung mas konting variables, di ba? Mas konting explanatory variables. Ano lang siya? Isa lang. Si Model 2, di ba? Alam mo yung 6, no? 6 o 5. Okay, so, ang tawag kay Model 1, restricted model because mas konti lang yung yung predictors, si education lang. So, the null hypothesis here, ito. The restricted model, which is Model 1, is better. So that's the null hypothesis here. Remember, this is a statistical test, and every statistical test has its own hypothesis. No? So i-run natin to. Alright, ito. Tignan nyo, guys. No? So Model 1 is the restricted model. Model 2 is the complete model. So what's our inference? The F stat is 28.202. So, ano ba ang ginagamit ng F statistics? No? Okay. So, ano yung p-value niya? Significant. Therefore, anong conclusion natin? Significant at 0.1%. What's our conclusion? We reject this null hypothesis. Okay. I-reject natin yung null hypothesis na si restricted model, which is Model 1, is better than Model 2. Therefore, statistically, we can show that Model 2 is better than Model 1. Nakita natin via AIC, via BIC, and via ANOVA. Okay? So with that, guys, next meeting, lagay ko lang dito. Lesson April 11 and review. Para guided lang. So next meeting, guys, tapusin natin to lahat. Okay, hopefully, kaya na natin matapos lahat to. Kahit 500 dyan, no? Matatapos natin lahat ng Kasi magaan tayo, we will do OLSRR. Let's now the stepwise regression using the OLSRR package, yung automatic na stepwise regression. Okay, thank you so much guys. I'll stop recording already.